Video I am going to discuss weighted mean, median and mode. So in simple arithmetic mean, all the items have the equal importance. Okay, so but we can now, if it is the case is, it may be possible that all the attributes are, or all the values are not equally important. In this case we may use weighted mean. Suppose x is equal to 1 2 3. So if you apply simple mean, so the answer is 1 plus 2 divided by 3, that is 6 by 3, it is 2. 2 is the arithmetic mean. Now if weights are there, say 1 2 3, suppose second is a much more important, so we can assign weight. So 1 3 1. So second one is a much more important. So in this case, to calculate the weighted mean, we use the formula summation of wx divided by summation of w. W is nothing but a weight. Okay, so you can calculate the summation of wx. So it is 1 6 3. So weighted mean for this particular data is, it is summation is what, 10 divided by weight, and weight is 5. So the arithmetic is so now unfortunately or fortunately both the values are same. If weights are different, you can get different weights. Say 1 2 3, weight say 2 3 1, okay, or say 2 2 2 2 3 3, okay. So wx will be 2 6 9. So weighted mean is, say, summation of this 17 divided by 8. Okay, so 7 8, and wx is 75, so it is something 17, say, so it is, the arithmetic means a 2.12, so on. Okay, so weighted mean. So application of weighted mean. Now suppose we have one data set for the student where we store the student marks. Clear? So suppose in this particular table, students are there, student marks are there. Say for example, say physics, chemistry, mathematics, English 1 and English 2. So the roll number, say roll number 1 2 3 4 5. The marks obtained, say 95 96 99 45 46, okay, or 45 32 25 99 98, or 65 67 68 98 67. Now here, if the purpose is different, now suppose we want to send few students to China to teach English. Okay, now to teach English, so these two marks are important. Suppose the marks are, so subjects are S1 S2 S3 S4 S5. So we can say W1 S1 plus W2 S2 plus W3 S3 plus W4 S4 plus W5 S5 and W1 plus W2 plus W3 plus W4. So that is nothing but the weighted mean. Now if we want to send few students to China to teach English, so we just give more weights to W4 and W5. So we can assign the weights like this way. Say 1 1 1 5, and now if fifth English, say E2 is much more important than E1, so you can assign more. Or suppose we want to send few students for the science project. Okay, so you can give more weights to the science subjects than the English. Here the attributes are not equally important, so situation to situation we can vary the weights and we can calculate different weighted mean, and we can apply the different data analysis concept. Okay, Next we talk about the median. So what is median? Clear? So what is median? Now the value of the variable which divides it into two equal parts. Okay, suppose one data is there, so here it is minimum and here is a maximum. Identify the value which is median. It divides into two equal parts. So left portion is the 50% data and right portion is the 50% data. So this is a median. Now for the raw data, suppose we have odd numbers of data, say 1, 3, 9, 12, 30. So what is the median value? So the middle value is 9, so the median is 9. Clear? Now if even number of data are there, say 1, 3, 9, 10, 12, 30. So the middle values are 9 to 10. So we can identify the median value, say 9 plus 10 divided by 2. So that is 9.5. So for the even number of data, so for this particular data, the median is 9.5, and for this particular data, the median is 9. Okay. Now, so we can assign a formula type. Suppose we have a odd number of data, say 1, 2, 3, 5, 6. So odd number of data. So this will be the median. So how to get the median value? So suppose indexing are 1, 2, 3, 4, 5. So first index plus last index by 2. So first index plus last index by 2, it is 3. So third data is the median. Okay, so if it is odd number of data, so the first index plus the last index, assume 1, 2, 2n by 2 data is the median. Okay, so first index plus nth index by 2 is nothing but a median. Now if it is even number of data are there, so if even number of data are there, say 1, 2, 3 to n, so we can say first n by 2th data plus n by 2 plus 1th data, and average of this is nothing but a median. Suppose we have a data 1, 2, 3, 4, 8 and say 12. So 1, 2, 3, 4, 5, even number of data are there. So nth by 2, so indexing are 1, 2, 3, 4, 5, 6. 6 by 2, 6 by 2 is a third data, that is 3, plus 6 by 2 plus 1, fourth data, that is 4, and average of this, that is 3.5 is the median. Okay. Now suppose we have another data, say 8, 6, 5, 2, 12. Now can you say what is the median value? So please remember, before applying the median, we have to sort the data. So sorting is what? 2, 5, 6, 8, 12. So the median value is 6. So 6 is the median. Okay. Now, how to calculate median for the ungrouped frequency table? So suppose we have a data 1, 3, 8, 12, 16, 20 and 31. The frequencies are 3, 6, 5, 10, 8, 2, 1. First of all, identify the cumulative frequency, the new term. So cumulative frequency. First of all, we have to identify the cumulative frequency. So how to calculate the cumulative frequency? So same as 3 plus 6, it is 9, 9 plus 5, it is 14, 14 plus 10, it is 24, 24 plus 8, it is 32, 32 plus 2 it is 34, 34 plus 1 it is 55. Calculate n by 2, where n is nothing but summation of the frequency. Next, identify the CF just greater than n by 2. Identify the CF just greater than n by 2, and corresponding value is the median. So n is 35, n by 2 is 35 by 2, it is 17.5. Now just more than 17.5 is 24. So corresponding value 12 is the median. Are you getting? So in this way we can calculate median for the ungrouped frequency table. Next, median for the continuous frequency table. Okay, so the formula is median is equal to L plus H by F n by 2 minus C, where L is the lower limit. L is the lower limit of the median class. What H? H is the class interval, F is the frequency, N is the summation of the frequency, and C is the cumulative frequency of the class preceding the median class. Okay, cumulative frequency of the class preceding the median class. So you can take one example, simple example. Suppose we have a data 20 to 40, 40 to 60, 60 to 80, 80 to 100. The frequencies are, this is the class 2, 6, 12, 3, 1. Okay. So first of all, we have to see what is the median class. What is the meaning of median class? Okay. So how to calculate the median class? So first of all, we have to calculate the CF, cumulative frequency. So how to calculate? So already you know how to calculate cumulative frequency. So 2, 6 plus 2, 8, 8 plus 12 it is 20, 20 plus 3 it is 23, 23 plus 1 it is 24. And summation of this frequency is nothing but a 24. Okay, so this is nothing but our in 24 frequency, total frequency. So first of all, identify the median class. Okay, so already you know, calculate n by 2. So n by 2 is 24 by 2, it is 12. Identify the CF which is just more than n by 2. So CF is 20, which is just 12, more than 12. So the median class is this. This is nothing but our median class. Clear how to calculate the median class? Now we'll get all the values. So already you know the formula of the median. It is L plus H by F n by 2 minus C. So in this particular, L is the lower limit of the median class, so 40. So L is equal to 40. H is the class interval, so 60 minus 40 it is 20. F is the frequency of the median class, which is 12. N is nothing but 24, and C is the cumulative frequency of the class preceding the median class. So median class is this, so C is nothing but this one, preceding cumulative frequency of the median class. Okay, so this is nothing but our C. So C is just equal to 8. So just calculate this one. So L is 40 plus 20 by 12. Okay, n by 2 is 24 by 2, it is 12 minus 8. So 40 plus 20 into 4 by 12. Okay, so just calculate 6.67. Okay, so the median class is, the median is, so the median is 46.67. Clear? Now in this way you can calculate the median. Now we will see merits and demerits of the median. So the merits is, first means it is rigidly defined. Second, easy to understand and calculate, not affected by extreme values. It's very important concept. Median is not affected by extreme values. Suppose say 5 5 5 85. Okay, so the mean is 25, but okay, mean is 25, but the median is 5 plus 5 by 2, this 5. So from the median, if extreme values are there, so in this case we have to calculate the median, because median is not affected by the extreme value, but the mean is affected by the extreme values. And it can be calculated for distribution with open-end class. Okay, suppose open-end class means suppose this value is not there, or this particular value is not there, still we can calculate the median value. Okay, but if okay, so it cannot be calculated. Now demerits. So first, if it cannot handle missing values, suppose few missing values are there, suppose here 6 is not there, so we cannot calculate the median class, we cannot calculate the summation of n, and we cannot calculate CF, and as well as we cannot calculate n by 2. That means we cannot calculate the median. And another demerit is sorting is required. Okay, so if the values are, suppose raw data are there, say 2, 8, 4, 6, 13, 8, 7. So first of all you have to apply sorting, and then we have to use sorting, then you can use the median class. And already you know, in computer science, so obviously for sorting we should use computer. Now for computer based sorting algorithm is, if you have the limited memory, then you can use quick sort, where the complexity is n log n. But if you have sufficient memory, you can use any other types of sorting algorithm, so that the complexity will be n. Okay, now next important measure of central tendency is the mode. Okay, I forgotten another limitation of median is, if the data is qualitative data, we cannot calculate the median, because we cannot arrange in order, so we cannot calculate the median. Now mode. What is mode? Mode is the value which occurs most frequently in a set of observations, and around which the other items of the set cluster densely. Clear? Suppose we have a few data, say red, green, blue, red, 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 green, green, red. So what is the mode value? So we identify how many red are there, how many green are there, and how many blues are there. So green, say how many reds are there? 1, 2, 3, 4, 5 reds. How many greens? 1, 2, 3. How many blues are there? Single. So the maximum frequency is 5. So the mode is equal to red. Okay, so that means if the qualitative data are there, so easily you can use mode. So what is the application of mode? Suppose the values are 1, 2, 8, 12, 16, 20, and the frequencies are 2, 8, 12, 33, okay, and say 12. So what is the most mode value? Identify the most frequency, so mode is 12. So but what if maximum frequency is repeated? Okay, maximum frequency is repeated means, suppose this one is another 30 is there, so the mode value is, another mode is there, so which one is the mode, 12 or 16? So very difficult to identify. So if it is bimodal, so there are some terms: unimodal, bimodal, and multimodal. If there is only one mode is there, it is called unimodal. If two modes are there, then it is called bimodal. If number of two modes are there, it is called multimodal. So if it is bimodal or if it is multimodal, it is very difficult task to identify the mode. Clear? Next, if there are irregularities in the distribution, we cannot calculate mode. If maximum frequency occur in the very beginning or at the end, then very difficult task to identify the mode. Okay, so we'll talk about this detail later. Calculation of mode for the group data. The formula is L plus H f1 minus f0 by 2f1 minus f0 minus f2. So what is L? L is the lower limit. What is H? It is class interval. What is f1? F1 is the frequency of the modal class. Frequency of the modal class. Okay. What is f0? F0 is the frequency of the preceding of the modal class. Frequency of the preceding of the modal class. When what is f2? Frequency of the succeeding of the modal class. Clear? Now you just see one example. Suppose we have class and the frequency. So 0 to 20, 20 to 40, 40 to 60, 60 to 80, 80 to 100. The frequencies are 2, 4, 12, 3, 1. So first of all we have to calculate the modal class. So how to calculate the modal class? So identify the maximum frequency. The maximum frequency is 12. So this is nothing but our modal class. Okay. Now we can get all the values easily. Say mode is equal to L plus H f1 minus f0 by 2f1 f0 f2. So what is L? L is the lower limit, that is 40. What is H? Class interval 60 minus 40, it is 20. Okay, it is class interval. So what is f1? That is modal frequency 12. What is f0? Preceding. F0 is the preceding frequency of the preceding of the modal class. So 4. And what is f2? It is 3. So this is f2. Okay. So what is mode? Mode is equal to L. L means 40 plus H is 20 f1 minus f0 divided by 2 into f1 minus f0 4 minus 3. Okay. So 40 plus 20 into 12 minus 5, it is 8. 24 minus 7. Okay. So 40 plus, it is 160 divided by 17. Okay. So if you solve this one mode is there. Suppose sometimes you cannot identify the mode. Now there is one point we have discussed about that. If a value is, if the frequency, maximum frequency occurs in the very beginning or at the end, we cannot calculate the mode. Suppose maximum frequency is somewhere here or maximum frequency is somewhere here. You cannot calculate the mode because here you can give the f1. So how to get the f0? Okay. Or if the maximum frequency here, you can get f0 and f1. How to get the f2? So if the maximum frequency is beginning or at the end, we cannot calculate the mode. So in this situation, there is one formula. We can use this particular formula. So the formula is very popular. Mode is equal to 3 median minus 2 mean. Okay. So if you are not directly calculating the mode, you just calculate median and mean, and from this particular median and mean we can get the mode value. But we may use this particular formula if the data distribution is symmetric. Okay. Now next, merits and demerits. So merits of the mode is easy to calculate, not affected by extreme value, can handle open-end class, and it can and the most important is it can handle qualitative data. Demerits, not possible to handle multimodal. Obviously if multimodal data is there, it is not possible to calculate. It is not based on all the observations. Okay, so mode is not based on all the observations. Further mathematical treatment is not possible. We cannot use medium mode value for the further mathematical treatment. And finally, it is based on the sample. These are the limitations of the data. Okay, that is the end of this particular video.